In this video, I will be covering what the heat transfer coefficient is and how Particleworks can help to improve the cooling of your systems and streamline your design process. The heat transfer coefficient, or HTC, is a measure of how much thermal energy is being drawn out of a system between a fluid medium and a surface. The advantage of simulating the HTC rather than the full thermal profile is that fluid stabilization timescales are far shorter than thermal timescales. For example, in the case of a piston cooling simulation, we will achieve a steady fluid flow, usually in a fraction of a second. However, we may not achieve full thermal equilibrium for several minutes. Simulating the oil jet for several minutes is a waste of computational time and would take far too long to be an effective step in the design process. What we suggest instead is to simulate the fluid medium until we have achieved a stable flow. From this simulation, we can export the HTC on the surface of all components of interest. In Particleworks, we export the HTC in the form of a mapping which is written to a CSV file. From here, the CSV can be used as the boundary condition for a finite element analysis to calculate the full thermal profile within the components without having to explicitly simulate the fluid for the entire time. Particleworks calculates the HTC between a fluid and an isothermal boundary using different Nussel number correlations for laminar and turbulent flow. In the newest version of Particleworks, we are also able to script our own calculation for the HTC. This is useful when the standard Nussel number correlations are not appropriate for the type of flow you are simulating. For example, when simulating an impinging jet, such as a piston cooling jet, the standard flat plate correlations underpredicts the HTC, so we apply a more accurate correlation that we have found through data-driven research. In Particleworks, pre-processing, simulation, and post-processing are all done within a single GUI. This means that creating your model, running the simulation, and exporting the HTC map is one single, simple process. And now with direct integration with FEA tools, cooling simulation has never been so easy. Particleworks is mesh-free, allowing for far faster setup and solve times. This, coupled with the ability to run on multiple GPUs, means that you can go from CAD to results in only a matter of hours. Particleworks HTC predictions have been validated in industry for different kinds of applications, from piston to e-motor cooling, making it the clear choice for all free surface cooling simulations. For more information about Particleworks and its capabilities, please visit www.particleworks.co.uk or contact us for a demonstration.